In the last video, I talked about time zones, which are made up of a UTC or GMT offset plus regional rules for daylight savings differences. I want to start this discussion by first looking at the Zone ID class, which comes with a lot of helpful methods. For this video, I'm going to start with a new project called More Time. I'll start by calling a static method on the Zone ID class, which gives you the current zone you're located in or that your system is using if different. This will be different for you depending on where you're running it from. For me, that's Australia/Adelaide. Java comes with a list of supported zones, and I'll show you how to get that list next. This is another method on the Zone ID class, and it returns a set of strings. First, let's see how many time zones there are. I'll use zoneid.getAvailable zoneIDs.size and just call that in my println statement. Running this. I get 603 zones, but this number may and probably will change over time. Why so many when there are only 24 hourly offsets possible from the prime meridian? Well, not all offsets are by the hour. Some are by the half hour, and a rare few are offset with quarterly hours. In addition, any region could have different time rules like daylight savings or standard times. I'll use a stream to print these out sorted. If I run this code, I'll see all 603 printed out. The majority of the zone IDs are in the format region/city, which you can see. I'll change my stream to just filter on those in Australia. I'll use strings starts with method passing at Australia. Now you can see all of Australia's time zones. I can create an instance of a zone using the ofFactory method and one of these IDs. I'll do this in the stream pipeline using the map method. I'll call map and create a new instance of zone ID, passing it the current string. Notice that IntelliJ wants me to replace that with a method reference, so I'll do that now. Running this. I don't see any difference in the result. The toString method on Zone ID simply prints out the ID. The Zone ID class has other methods and fields, so I'll change what I'm printing out, switching to a lambda expression. I'll print out the ID using the getID method and the rules which are part of the Zone ID class. Running this code, I'll now see one rule for each of these, which shows me the UTC offset of each of these time zones. Australia has a couple of regions where the offset is by the half hour, and you can see that with Adelaide, Broken Hill and Darwin, for example. You can also see that Eucla is offset by 8 hours and 45 minutes. There are a couple of other things I want you to notice here. First, the IDs don't have spaces. Where you'd expect a space in the name of a city or town, like Broken Hill, an underscore is used. This is important to remember if you use these IDs in code. Also notice that the offset hours and minutes are separated by a colon, which is a little different from what I showed you in the previous video. Moving on, I'll change my filter to America. America represents cities in both North America and South America, so that can be quite a large group. I'll filter by America/N as the city or region as well, if I run that. I get some interesting results. Nassau is in the Bahamas. New York, of course, contains New York City, but it's not just New York City. It's a zone used for the East Coast region of the United States. Next, look at North Dakota. This time zone has additional levels. North Dakota is a state in the US, and some parts of the state participate in daylight savings, and some don't. It might be important, if you've got customers or employees in North Dakota, to understand more information about where they're located in that state. Here I've shown you America/New York, which is the preferred ID for the time zone. That is UTC -5. Keep in mind that not all cities have zone IDs. For example, Boston and Philadelphia, large cities on the east coast of the US, do not. They'd use Zone ID, America/New York. Some of these time zones go by alternate names or older time zone names, and America/New York is one of these. Let me change that filter to just US. Running this, I get 12 time zones that are more regional. Cities aren't listed here, but some states in the US are. US/Eastern is another older or more traditional time zone ID for America/New York. I recommend you use the time zones specified on the website I showed you in the last video for the region and city you're targeting. If you've looked on the internet for time zone code in Java, you may run across code that uses the class java.util.timezone to provide a list of zone IDs. Timezone is a class that predates zone ID, and you should strive to use zone ID when you can. If you have to maintain legacy code, just understand this class is there and supported for backwards compatibility. Let's see if there's any differences between the zone IDs that each of these classes gives us. First, I'll set up a set with strings, calling the variable jdk8zones, assigning that the result of a call to zoneID.getAvailable zone IDs. A similar method exists on the timezone class called getAvailableIDs, but this returns a string array. I'll set up a second set of string and call it oldway, making that a new instance of hashset, and using set.of to create a set out of the string array. I'm going to use some set math to see what differences there are between these two. First, I'll call remove all on JDK8 zones, passing it the oldway set of zone IDs. I'll print JDK8 zones, which should show me what was in the old zone IDs that's not in the JDK8 zone IDs set. Running this code. As you can see, this simply prints a pair of square brackets, so that tells me that the class zone ID returns all the same zones that timezone does. But is this true the other way around? I'll swap JDK8 zones and oldway, and on the next line, I'll print oldway instead of JDK8 zones. If I run this, I actually do get some time zones listed. This means the timezone class has time zones that the newer zone ID doesn't. These are really daylight savings codes, but once were valid zone IDs. Why aren't they part of zone IDs list? Well, their use is being discouraged, although not officially deprecated. These codes can be confusing because they don't really distinguish between daylight savings or daylight standard time, and there may be duplicate codes across countries. What happens if I try to create a zone ID instance using one of these codes? I'll do that next. I'll just pick bet and create a local variable of the same name, assigning that the result of the factory method zoneID.of, passing it bet, and I'll print that out. If I run this code, I get an exception, unknown timezone ID, bet. That doesn't seem very backwards compatible, does it? But this method has an overloaded version for just this kind of code. I'll add the second argument, which takes a map of IDs, and I'll get this map from a static field on zoneID called shortIDs. Now if I run this, I get the new zone ID, the old one that bet represented, for Sao Paulo in Brazil and South America, or just America in this ID. Perhaps you are wondering where the daylight savings information is. That information is in the rules, but to look at it, I'll need the context of an actual point in time. Before I do that, let's all set our clocks, if you will, to the same time and place. I'm going to do this using a method on the system class, setProperty, that lets us set system variables. There are other ways to do this, for example, passing it as a command line argument when starting up the JVM. If you do set this property this way, using the user.timezone, this should be set in the main class, as I'll do here, or in the entry point for your application. It needs to be set before any date manipulation code because it's cached, otherwise it won't have any effect on the JVM timezone. I'll add this as the first statement in my main method. Just to make it interesting, let's use America/Los Angeles. I can call setProperty on system. The first argument needs to be a string literal, formatted as I show you here, so use a .timezone. The second argument is the zone ID, so America/Los_Angeles. If I run this, I'll see that the first statement in my output confirms that the time zone is America, Los Angeles. I'll create a new local date time at the end of the main method and print that out. Running that. I'll see the date and time printed as if I lived in California or on the West Coast in the US. If you're located in a different time zone, hopefully you can appreciate that the date or the time is different than what you had previously. Let's look at the instant class next. You can create an instance of this class also using the now method, just as I did with local date time. I'll call my local variable instant now, assigning it what I get from calling now on the instant class. And I'll print that out. Notice when I run this, I don't get the same time as I did with the now variable. It has the same default format as a local date time, with the date followed by the capital letter T, then time including nanoseconds. But the instant output includes a trailing Z character, The Z character in this output indicates that this time is really UTC, or a 0 offset. I can go back to my system.set property method and change that time zone to just UTC. If I rerun the code, notice that my local date time and the instant date time appear to be the same, with the exception of the trailing Z and maybe some nanoseconds. I can change the time zone to GMT as well in that statement, so I'll do that next. And running that, I'll get the same results, remembering again that GMT may be off at most by less than a second. My local date time and instant appear to have the same date and time. I'll revert that code back to using America/Los_Angeles. I'm going to end this video here. In the next video, I'll continue to look at the instant class as well as zone date, time, duration, and period.